In this video, I'm just going to talk through page 3 of lesson 6. So you need to choose one of the synthesis reactions that we watched play out from the previous page. I'm just going to choose the zinc and iodine synthesis. So if we scroll down, this is what I've already sketched in. I've already sketched in my zinc on its own and then my iodine on its own, and then here I have this together. Now remember, we have not talked about how molecules come together and actually form. We haven't talked about the structure of that. So as long as you have them in contact with each other or showing that they are connected somehow into one molecule, you're fine. So here, for simplicity, I've just started with equal amounts of kinetic and potential energy in the system and the surroundings, okay? And just like before, we want to think through what is actually happening here. So we know that this is an exothermic reaction. Exothermic means that we have energy transferring from the system to the surroundings, and we can pick up that temperature, or we can pick up that change in energy through a change in temperature. So again, because there is a shift in temperature, we're going to have the kinetic energy of the surroundings increase. So we started off with 1, 2, 3, 4 boxes. So I'm just going to add another few boxes. Okay. So now I have 1, 2, 3, 4, and then I have 5, 6. So I added 2 boxes here. So that those 2 boxes have to come from somewhere. The kinetic energy of the system, we can assume, is just remaining the same. Where it's going to be coming from, because we're going to assume that the potential energy of the surrounding is also the same. Where it's coming from is the potential energy from the system. So I want to just make sure that we have that decreased. So just to kind of recap this, I have an exothermic reaction, meaning that I have energy moving from the system to the surroundings. That is picked up by an increase in temperature in the surroundings. So that's why I've specifically chosen to increase my kinetic energy of the surroundings. And then I'm taking that from my potential energy from the system, because the system's kinetic energy is not actually changing.